Hi, today we're gonna see how to solve other string problem. Well, basically it's asking us that after deleting exactly k characters from the string, and rearranging in any order, we can form a palindrome, and we have to print yes if it's possible or no otherwise. So let's see with an example. Let's take this one. Okay, so let's see, what is a palindrome? First of all, a palindrome is any string that is the same backwards and forwards. So it means in the original order and in the reverse order. So let's call this original and let's see this as reverse. So the string here, the character here is gonna be here and so on. So let's see our string. Let's have A, B, 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 A, and let's see, this is gonna be here, then here, 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 and here. So yeah, this is a palindrome. Alright, this is palindrome. So let's see another example. So if we have, let's see, 4 letters, and we have B, C, A, and D, and we place in the reverse order. It's gonna be D, A, C, and B, and this is not the same string, so this is not palindrome. Alright, so let's see, we can recognize a property in the palindrome that if we place always pairs, we will always end up with a palindrome. Let's see why. If we have an A, we place A. We have a B, we place B. If we have again B, we place B. So we know that it's gonna be a palindrome because we are placing the first in the beginning and the first in the same at the end. So we are placing same beginning, same end, same beginning, same end. So this ensures that we have palindrome. So if we have even number of the same characters, it's a palindrome, and this also will leave us with an even length. So if we have an even length, we know that all of them must be pairs. So let's see, if we have like 4 B's, we know that we have 2 pairs. So yeah, it is. We have just 1 pair, yeah. So at the end we just have to check that we can form pairs. So the number of any character must be an even. What means this? It means that after doing the division, we just end up with 0. It means we can get an exactly division by 2, so we can form pairs. For example, with 5, we're gonna end up with 1. So this is odd. This doesn't satisfy. But this is only happen if we have an even length. Let's see what happens if we have an odd length. Okay, so let's see. Let's see that we can have we have 5 length. So for this we know that we can also place a pair here, but in the middle we know that we can have always an odd number. Let's see let's see another example like A, B, C, B, A. This is also correct, and we just have 1. Here we have 3, and we can also get with all of them be the same. So now we end up with 5. So for odd length, we will just have exactly one odd character, and all the remaining are gonna be pairs. So let's see exactly with this example. So let me clear this up. Alright, it's enough. So let's see with this. So let's count the number we have. We have 1b, we have 2 a's, we have 2 c's, and we have 1d. So at the end we have 6 letters. Alright, so this is saying we have to remove exactly 2, so we're gonna end up with a 4 length. So 1, 2, 3, 4. So as we saw, we have to always get an even pair. So let's see how many characters we have to remove for v in order to get a pair. We have to remove 1, so we're gonna end up with 0. And for this, it's already a pair, so it's 0. For this, it's already a pair, so it's 0. And for this, we have to remove 1. So to guarantee that we're gonna end up with even pairs, we have to remove exactly 2 characters. Okay, so let's see, we can remove at least, well, not at least, it's exactly we have to remove 2 characters, and here we can remove 2 characters. So for this, we know that it's gonna be chi minus 2. So we end up with k equal to 0. So yeah, for this, yes, we can. Let's see if we can place AA and CC. Alright, so that's gonna be okay. So let's see another example to make this more clear. Suppose that we have A, B, B, we have, okay, we have 6 and we just want to remove 2. We are gonna remove 2. Alright, so for this we have 4, we have 2. So we have to remove 0 and we have to remove 0. So chi prime is gonna be 0. So chi minus chi prime is gonna be 2. So let's see, if k is even, we know that it's okay. Alright, if k is even, we know that, yeah, it's alright. And it's also warranted that we cannot remove more than we have, so we just need to check this part. So yeah, so we know that after removing the chi prime, we must end up with a even. So let's see just what happened when we have a not quantity. So let's check. If we have, let's see, A, B, C, we have, I don't know, we have 6 minus 1. We want to end up with 5 characters. So for this, we know that our key is 1. And for the odds, we must end up with a not and all of them pairs. So let's see, we have 2 A's, we have 2 B's, we have 1 C, and we have 1 D. Okay, so let's see. So to make it even is 0, 0, 1, 1. Okay, so in order to get them all even, we must remove 2. But we also know that we must end up with a not. So in order to make this easier, we can check, like, if there's a not number, like if this is greater than 0. If this is greater than 0, we know that we have one not. So at the end, we just have to remove 1. So B is gonna be 1. Sorry, so chi prime is gonna be 1. So, and now it's again as the same. as the previous exercise. It's gonna be chi minus k prime. It's gonna be 0. This is even, so yeah, it's alright. So let's see. For this we can have A, B, B, and end up with C. So we already know how to solve this problem. So let's start on coding it. So let's see, they are giving us first the number of test cases. There are 14. They won't exceed this quantity, and then they will give us any k and the length of the string, and k the most characters that we can delete. And as here they ensure us that n is gonna be always greater than k, so we gonna end up with an empty string. So let's start. So well, I'm gonna use C++. So let's see. So I'm gonna read the number of test cases, t minus minus, and I'm gonna read n and k. So let's see, and then they are gonna give us the string. Okay, so as we said, we have to count the number of times that they appear. So we're gonna count them plus plus. Alright, so now we have the number that we have. So as we said, we're gonna check if, let's call this a size. So this is gonna be n minus k, and we're gonna check if we have an odd. We just know that we're gonna do k plus 1. Okay, so at the end we're gonna always end the same. We're gonna check the same, like how many odds we have. So let's see, for count, we're gonna see how many odds do we have. So if it's an even, we're gonna add 1. So at the end we know that if the ones that we have to remove is greater than k, we're just gonna print no. Well, maybe I'm confusing. It's also worse, but let's keep with our algorithm. Like if it's this, we're gonna remove 1 odd. So otherwise we're just gonna check that if, okay, let's see, k minus odd, and let's check if k is even, then it's yes, otherwise it's not. Alright, so well, this is our solution. So let's check it. Let's check if everything is okay. Alright, we got and accepted. Have any question about any problem? Feel free to comment. Thank you.